Yeah, for sure. And you need to again, take care of both the sides, right? You need to give the most relevant recommendations. At the same time, you need to grow,
Yeah.
create the right set of creators. And then how do you do this? It's going to be very interesting. Other ranking events used to be like, oh, what percentage of video you will watch, right? Again, there that will be more biased for shorter videos, because in shorter videos, if it's a 10-second video, you can easily watch 7 seconds and you are like 70% through it, right? If you have a long video, user will generally
Yeah.
watch more. So
Yeah.
both of these technically don't directly work. So now you need to come up with like new ranking events.
All right. So, hello and welcome everyone to who's ever listening to this particular podcast. Today, I have with me Amey Dharwadker. He's a machine learning tech lead manager at Meta, supporting Facebook's video recommendation ranking team, working on building and deploying personalization models for billions of users. He has also been instrumental in driving a significant increase in user engagement and revenue for the company through his work on newsfeed and ads ranking machine learning models. As an experienced researcher, he has co authored several publications at numerous AI and ML conferences and patents in the field of recommender systems and machine learning. He has an undergraduate and graduate degree from National Institute of Technology, Tiruchirappalli in India, and also from Columbia University. Amey, welcome to the show. It's nice to have you finally here.
Thanks a lot for having me. It's my pleasure to be here.
So, to learn more about your introduction, can you tell us how did you get into recommendation systems and what was your background before that?
Yeah, sure. So I completed my undergraduate degree in electronics and communication engineering from National Institute of Technology, Tiruchirappalli in India. And at that time, most of my background in machine learning was through self-learning. I had taken a couple of elective courses in computer vision, and that really amazed me, like the ability to have computers see like humans do. Sort of, I think that was really amazing to me. So I continued my work. I did an internship at the Indian Institute of Science in Bangalore, working on computer vision, mostly on like scene text recognition at that time, which is basically trying to understand texts in the wild. For example, like on billboards and stuff like that, written in different styles, formats, on different surfaces, and so on. From there, after graduation, I moved to analog devices. I worked on computer vision based autonomous driver assistance systems. And this is like, you can consider this as like a predecessor to self-driving cars, where we're just trying to understand what's happening around the car and give warnings so that the drivers can act on it. And examples here can be like lane detection systems, traffic sign recognition, or even like if you're too close to another car in front of you, like forward collision warning and so on. Worked there for a couple of years, moved to Columbia University for graduate studies, where again I focused on computer vision and machine learning. And during that time, I interned at Facebook in the summer of 2014, working on ads ranking. I think that was my very first exposure to a ranking system which works on real world users and on millions of users actually at a time. So that really was what like got me started. I think one thing I really like about recommender systems, I think it's talked about a little less, is that the real world impact it has on a lot of users. And I mean, in terms of just user value and also in terms of like dollar value,
Yeah.
the real world impact it has, like ads, entertainment, search, e-commerce, anything you think of is a recommender system today. And my I always thought like this was like what drove me a lot. So that and I think now people are realizing the value. So there is, I mean, computer vision, reinforcement learning, even NLP large models these days stay in limelight, but I think people
Yeah.
are understanding the value that recommender systems machine learning brings to the world now.
Yeah, definitely. I think recommender systems are more used by end users nowadays more than any other kind of systems, right? Because we
Yep.
have tons of things that needs recommendation or in terms of like ranking. And I think starting from Netflix to any kind of videos that you see on YouTube or any other platforms, because you have an influx of new content being produced every day. So it becomes like a game of who can get your attention in the least amount of time, which is like a big problem from both the ends, like even for users and also for the companies who are hosting these content.
Yep.
So yeah, I definitely love that. Yeah, as in like the transition makes more sense because if you're working at that scale and with the internship experience, it gives you a brief trailer into what really stands for you. So yeah, that's interesting. So can you tell us more about like what did you first of all, because you mentioned internship? So what was the project that you briefly worked during your internship that built your interest in recommender systems, and versus now when you're working as a tech lead at Facebook? So what kind of projects you are currently handling?
Yeah. So at that time when I was interning, it was more around search ads. Like we didn't have a product on search ads, but it was mostly around like, oh, if users are searching for something, then ads on something related is like should rank well, and users should see ads. Like they're doing some organic searches. For example, you're organically searching for whatever, like baby strollers, right? So you should be able to see ads that we know that you are interested in baby strollers. So using what you're searching for in helping you serve like relevant ads. I think that was the problem at that time. Now I'm working on video recommendations ranking for the last 4 years around in Facebook. And the work there is mostly around like building user personalization models, understanding like user satisfaction, what actually user satisfaction means. We can go in detail on it like later, and then optimizing for it, right? So to serve the most relevant video recommendations to users. It's again like a large scale, Facebook scale. We can go into the scale and stuff like that. If that, yeah, it's
Yeah.
interesting.
Yeah, definitely. So you mentioned about user satisfaction. Like, so how do these metrics really translate into real world when we are building solutions in terms of, let's say, even machine learning tools or any kind of technological tools? Like, how do you map a particular metric that has, let's say, any kind of business value, and how do you map to like an algorithm over here?
Yeah, I think traditionally, right, like machine learning systems have been like measured on only like accuracy or
Yeah,
recall or precision and so on. But I think here in video recommendation systems, and especially in any like real world system, it's very multi-dimensional. So, for example, you need to really understand what the user wants, right? For example, users may want to like discover new items. They may want to like explore a diverse set of items. They may want like the system to be very adaptive to their changing interests. So
yeah,
basically, we need to consider like multiple metrics apart from just accuracy. So, for example, like how well you are diversifying, how well you are exploring. Like there are metrics around like serendipity, which is like, oh, I'm seeing completely unexpected information, which is I would not get by just considering my embedding and the item embedding and so on. So there are like multiple sets of these metrics, because user satisfaction again is a broad concept. It's not only
yeah.
like, oh, getting something right. So I think that's where it's like very different as compared to what you see generally in theory, in the real world systems.
But I would be curious, like how do you record these kind of metrics, right? Because there are only few actions as a user that people would be doing. It would be like either, let's say, opening a particular ad or particular product, and then maybe not proceeding with it, or with proceeding with something like a buy, or maybe watching the whole thing. So how do you quantify these kind of subtle metrics that you can use to a would be like evaluate the model, and secondly the improvisation of these kind of tools? So like how do you, how like defining would be, I can understand like these kind of user satisfaction, but how do you quantify these metrics?
Yeah. Again, like for example, like diversity. For example, if you're trying to measure, right, you can understand what users have seen in the past or interacted with in the past, and you can kind of figure out like, oh, these are around like these 2 or 3 topics, right? So how do you kind of build based on all the user preference data as well as
Mhm.
what data you have on the items. For example, like items, I know like we have 3 interests A, B, C. User has seen like and or interacted with 10 items from A, 5 items from B, 10 items from C. You can kind of get like a score saying that, oh, how diverse their experience was in the last session. Or and these can be either session based or even like time based, saying that, oh, in the last one day they have interacted with this. In the last one session, like they got all these things. If they got very similar things in the session, that means the session is not diverse. There
Mm,
are metrics around even coverage, right? So because all these systems need it's user experience, but it's also like a multi-stakeholder marketplace, in the sense
yeah.
that you have users, who are trying to get the most relevant content. You have creators who are like getting trying to get more distribution for their content.
Yeah.
Advertisers who are trying to monetize, platform who's trying to like gain value by connecting all these together. So how do you serve all of these? For example, like coverage, right? We need to make sure that a lot of the good creators get coverage. At the same time, users get relevant recommendations. So you know there are multiple measurements around like both the sides, or around all the stakeholders. And of course, like there are trade-offs between these, and it's not very simple sometimes to say, oh, this candidate is definitely better, because there may be trade-offs between these systems. So I think that like measurement is a very, very big piece in its whole. Like there are like
Yeah.
teams even dedicated to just understand and improve it over time. Like you start with something simple and you improve it over time. That's how generally it works in industrial systems.
I see. Yeah, that's very interesting. Like, as in, like, it's like a min max algorithm kind of a scenario where you are trying to uh, you're trying to optimize for all kind of people and all kind of parties, because like you said, creators, users, and like ads revenue who are trying to promote that thing. So
Yeah.
it's like the platform sits at the core of these three intersection, trying to provide some kind of value to all of its roles. But
Yeah.
so, explain me the difference between, let's say, when you're working on video recommendations versus, let's say, the one that you worked previously before joining video recommendations was like news ad, and I would say like this would be much more product centric, right? Like, correct me if I'm wrong, but are there any differences between working on these two different kind of recommendation systems, and what are the differences if it's the case?
Yeah. So I think on video, right, understanding video content was a very big piece. For example, videos are very complex. They are multidimensional. And how do you extract like meaningful information from this content is key. So for
Yeah.
example, you have like a video, for example, of Ronaldo like scoring a goal, right? You have a 2-minute video. Maybe he scores a goal somewhere around 1 minute, 30 seconds, right? And just understanding that key point is also important, because users may drop off even before that, or some people may just watch that and drop off. And
Yeah.
so like that is very multidimensional. Again, like comparing that to if I'm sitting in my balcony just recording trees swaying outside with the wind, like how that video is different from this video. Again, it's not only about sports versus nature, it's like even more intricate. On product recommendations, or like in general, like on ads recommendations, what I found out was most of these products have very like kind of fixed attributes associated with them, and they're very structured information saying that, oh, this is the price of the item, this is the category. And advertisers are also incentivized by doing that. But on user recommendations, especially on videos, like now everyone is a creator, right? So
Yeah.
having that scale, having that diverse set of content, understanding what's happening within the video, I think that's a very big challenge there. uh,
I
yeah.
see. So how do you go about, like, is it something like event detection, or like what kind of tools like you would do in order to detect these kind of events? Because like you said, like, there is no way we can technically define if a person has a video of just randomly roaming around in forest versus Ronaldo scoring a goal, which obviously has some kind of relevance in terms of user engagement. So what kind of technologies, like, I'm not sure if you're allowed to say publicly, but like, I think, what kind of tools you would be using to detect these kind of events? Because it would be like a very interesting topic working from a research angle, right? Like, detecting the kind of event in general, like, because to the video everything is emotion. So how do you define these kind of moments from a technical standpoint?
Yeah, I can go over it. This, and again, this is not very specific to any one company. Like this is generally how large scale, systems, or these video recommender systems works.
Yeah.
So generally, what they do is like when you don't have any information about the video, you start with like the prior is a content embedding of some form. So either it is an average of some of the frames of the video taken at like equal intervals, or even some any other form. Like you can imagine that it's some form of content embedding, either it's like average of the frames, or it is like just a video embedding in general. So you start from there when you don't have any data about engagement. But as data starts to come in, you try to like use that even more, because engagement data we have seen is very powerful. The content data is starting as a prior, but for example, you see like what is the distribution of like uh, different duration versus how many people are watching or dropping off. So on YouTube also, for example, you can see on the bar on the lower end, right? You will see that graph.
Yeah.
So trying to understand that distribution and then optimizing based on that, I think that's what most people do. And there also, for example, you can imagine a video can be some form of a function like average or something of the viewers watching it. So
Yeah.
like, oh, these viewers generally watch like sports videos or football videos and so on. So this video is about football, and then based on their engagement, you can kind of move that video in the embedding space effectively. So that's generally how this engagement data, especially at scale, it's super powerful. So that's
Yeah.
generally how folks do it on these systems.
Yeah, it's funny that you mentioned the scale thing, as in like, because 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 I have known a lot of people who work on recommendation systems, and one of the biggest problems when you're not working on within industry, like problem is the data, right? Like, because like there are not many open source data sets where you can improve a model. Like for vision, we have lots of open source data sets where you can test your model and your algorithm, and you can say if it is better than the state of art. But that's not the case for recommendation systems, because there's literally no data, and most of the platforms are monetized, or they're creating revenue, so those data sets are not public. So can you explain in much more layman terms, like how does the scale play a role? Is it like, does it intimidate you working as a researcher, or does it provide you more power, or like more opportunities to build something that is creating more revenue? Like, can you tell us on the both the sides of like how does the scale play a role in building recommendation systems?
Yeah, I think scale is super important, right? So, for example, just to give you a sense of our scale, like, and most of these large online companies, I think, should be at similar scale. So we have like 2 billion plus daily active users. I think it's the latest earnings call that was announced. Large fraction of those watch videos, I think almost, this also was public as of 2021, like around 50% of time spent on Facebook is on watching videos. So it's a huge scale problem. And scale also on the user side, also on the item side, right? We have like billions of items in corpus. Everything is, all those like non-integrity violating items are valid for recommendations, like they're
Yeah.
valid candidates. And new items are being added every day. So every day there are again like millions of content pieces of content created. At this scale, like it's important. Like one thing is important, for example, is very basically like model training and serving cost, right? So for example, we are training on like multi days of data. If you increase the training cost significantly, it affects like a developer velocity. Like at least internally, everyone will be able to do changes a little bit more slower if you
Yeah.
increase the training cost. So that is important on the internal side. On the inference cost, if you increase it, like it's costing the company to serve the predictions from this model. So training serving cost is important. Also, one other interesting component here is on like how real time you need to be. So items are coming in every day. You need to really understand quickly what it is about, aggregate all those like user engagements, understand the content, because each content piece, the lifespan is short in general. Like you will get most of the engagement within the first few days, or a few hours even, depending on the type of content. So for example, like we have these again, like giving an example of sports, right? Cricket, right? We have Indian Premier League going on. There are two matches happening every day, right? So
Yeah.
you kind of one match, you show the highlights. It may not be relevant like the next day, right? Because you have two like three more matches by that time. So this content, like you need to understand it very quickly. Life cycle is short, so you need to kind of, a lot of ranking needs to happen real time. On the user side also, as I'm watching videos that I'm given a feed, if I watch videos on top, the bottom of my feed should adapt to what I have done on top. Like if I've skipped something or watched something, you
Mm.
need to adapt your recommendations very quickly. So I think those are like very big challenges at scale in general.
I see. I see. It's nice. Like, I'll put a bookmark to this particular topic, as in adapting, like the recommendation systems adapting to the trends. But one of the key problems, because like I said, like I have a lot of people working on recommendation systems that I've talked to in the past, and one of the biggest problems, like let me learn. from your perspective is the cold start problem, right? Like let's say you are being assigned to work on a particular product or particular project that needs to have a particular ranking algorithm. So you have tons of content and people are new to this, so like even the user engagement is not really uh, I would say crisp in terms of understanding, because I mean the users are still exploring and there's not relevant content. So can you define any, or because you are the expert over here, like can you define first of all what do we mean by cold start problem, and what kind of solutions you have seen, because working in the, because you have been actively in the research community, what kind of solutions that people have been using to tackle this cold start problem in recommendation systems?
Yeah. So yeah, I think cold start problem is where you don't have much interaction data, so that you can make recommendations based on that. Like past interactions are very important in general in recommender systems. So we say it's a cold start when we don't have those past interaction data. So cold start can be on both the sides, right? User cold start means we don't have much information about the user. Item cold start is where we don't have similarly much information about the item to understand it. So in this case, it's very difficult to rank these, and you need to bootstrap in it some way. So general ways of bootstrapping is, for example, if you're moving to like a new country, right? If you're launched in a few countries, if you're launching a product to a new country, we use like cross market recommendations. So trying to understand what's happened in one market and trying to get that same thing in another market. Other ways of doing this are like, see, for example, you are building video recommendations newly, but you already have photos or link recommendations and so on. Trying to see what is user done on photos and links to kind of move that information and bootstrap those video recommendations in that way. Also, like some other techniques that have been used here is to like incentivize user feedback in some way, so that users give feedback. For example, like if you're a new user, you might have seen when you sign up to some services, they will ask you, oh, what are the topics you're interested in? Like a sheet will pop up, and that's basically because like that information is used to like bootstrap when you don't know anything about these users. So generally, like as I said, you start with like content embeddings, understanding very basic preferences, and then move from there as you get engagement from the users.
And one of the, because you said like you will be using these kind of attributes from users that you can collect indirectly or directly over here. One of the common myths, and I think like people who do not understand how these algorithms work and how these platforms use these algorithms, is the fear. Like, right, like I mean, my data is being used and all those kind of claims that people make. So can you debunk this myth that like how exactly, like do you like as a person who is designing these kind of algorithms, I'm sure you use kind of anonymization or some kind of tools that can protect the user's privacy. So can you explain like why, like what is the part that normally these platforms definitely use in order to make sure that the integrity of these data are being considered, rather than just not being like explicitly used and exploited? That's like the common trend people tend to receive.
Yeah, yeah. I think all the data that is used is like uh, taken consent from the users. Also, like for example, like there is a lot of anonymization. As a person developing these algorithms, generally there is no visibility into individual metrics. So, for example, you cannot point out saying that X person did or interacted with ABC, because it's generally like you don't know what is X, you don't know
Yeah.
what's ABC. Everything is like hashed. Everything is looked at in an aggregate manner in general. So, for example, like even when you're analyzing experiments, it's like, oh, people in this area or like in this countries are engaging a lot with this kind of creator, right? Sort of, it's not like this person is doing this. So I think in general, like there is a lot of aggregation of data. There is like anonymization, hashing, all those techniques in how data is used and as well as accessed.
I see. I see. And one of the other parts of your profile that I've looked at is, I think you are also not just a researcher, but a person who has built these kind of systems and deployed these models. And this would be very curious even for me to learn, is like I have seen a lot of people, like it's relatively, I would say, a different challenge when we build these kind of algorithms, and it's a whole different challenge when you actually deploy these models into production level environment, because there are lots of things that can go wrong when you are deploying these models and these, like you said, like the real time adaptation and all those kind of stuff. So can you briefly shed some light on what are the challenges when we deploy these models? Let's say you have a model that can take input and that can generate output reliably, like whatever the case is. But when it comes to machine learning models that require certain kind of input being pre-processed and the outputs need to be interpreted in a different way. So what are the challenges when we deploy these models in real world and it is actively improving the engagement or any kind of metrics that is being deployed on? So what are the challenges over here?
Yeah. So there are multiple challenges, right? So one of them, for example, is interpretability. Like it's very difficult often to identify like errors or where the model may be biased and so on. And we need to do a lot of work to understand like these pockets of places where the model is not doing well. For example, which segment of users are hurt the most? Which segment of users is it like benefiting the most? Especially as you're more mature, the models are more mature, the opportunities also for improvement further will come in these pockets. So understanding that is very important even for like building your next roadmap for the future. So model interpretability is like one of these things. Also like currency, right? Like between the trade-offs, as I said, like not everything may move in the same direction. There may be different trade-offs. There is data drift, for example. Like all our
Yeah,
systems models need to be like training recurringly in fashion. So either it's like daily training or hourly training, or like depends on the application. But as models become less effective or less accurate over time, and data drift, so you need to be able to adapt to that data. So generally, you need to like retrain it. A lot of work goes on like even monitoring the metrics in real time, because if something goes wrong, all your metrics will tank. And especially for a large system, even if it tanks a little bit, at absolute value, it's like huge, right? So a lot of
yeah.
work goes on like even monitoring and making sure that these are like stable over time.
I see. I see. And are there any things that you have seen specifically from the architecture perspective? Like I think there are few things that can be specific to a deep learning architecture. Let's say, I mean, one of the key things that I can maybe share from my end that I have seen, and maybe you can pick up a similar tangent, is like I have seen one of the models that was deployed by ASU, and because we work closely with Mayo Clinic, there was this model being used. In real world scenario, and again, these are not as sophisticated as someone from an engineer at Facebook over here, because these are like academic researchers trying to just make sure that this is like an end-to-end working pipeline. Is There was a particular pre-processing tool that machine learning was using when you have an MRI scan being pre-processed, and then it was the input to the model. But there was this one hazy little, like I think when you create an MRI scan, it creates like if the person is moving, it creates like a blurry effect in the MRI scan. And when that was being input to the model, the output was blowing up a lot, and we were using the same existing pipeline. Nobody was able to understand what's going on wrong, and it was only like after a certain amount of iterations we figured out that this particular cohort, because of certain reasons, had people, like let's say after 100 people, there were 5 people who had blurry effects, and that was causing the whole issue. So these are the kind of things I feel are like lesser known by people, because the machine learning model is so sensitive to these kind of inputs that you would not expect, like if a human was analyzing that particular MRI scan, he or she would definitely point out, hey, this is like a bad image, let's not use that. But like to the machine learning model, it still seems like an input. So have you seen these kind of challenges specifically from an production environment, saying that, oh, we need to make sure that the model is able to handle these kind of inputs too, because then the mod like the pipeline fails in itself?
Yeah, I think there are like similar issues, and again, like it goes back to more about like finding those pockets. Sometimes it is found out after the issue happens, like as you said, right? Sometimes after the issue happens, we try to debug, on this data or on this segment, why does this happen? Sometimes it is you even catch it during the training or the evaluation phase. So we kind of generally how these systems work is you train, you have a time split. So for example, you train till a particular time, and then you evaluate on the future time and see how this model would have done.
Mm.
Due to like vanishing gradients. I think these all were problems that occur, especially in the beginning stages as you train these models and move to these bigger models, right? So vanishing gradients, for example, or
Mm.
something that causes like the model to return like a not a number, right? For example, somewhere in the middle layers that could actually
Mm.
screw up your final like prediction totally. So just kind of understanding these different layers, understanding outputs in different cases, evaluating. So we have like very strong evaluations. We try to look into like different buckets. Overall metric is a good one and it's a starting point, but we also try to do like more finer grained evaluations to make sure like initially there is no problem. But of course, like 100% problems couldn't be caught.
Yeah.
Sometimes they're caught after the fact, but then we try to incorporate those learnings to kind of again change these fine grained evaluations to, oh, next time we should also look into this, right? So that's like a learning that we get.
Yeah, that makes sense. And one of the key things that you just mentioned and also previously mentioned is the idea of like, first of all, is extracting these kind of subtle metrics that you can use to optimize the end goal that you are trying to achieve with these kind of scenarios. But I feel there would be definitely an optimal set of metrics that you can use to optimize the model, right? Because I mean, it's a commonly known fact that if you have, let's say, for any kind of vision model, just a computer vision model, if you have, let's say, 5 loss functions, the model will never converge because you are just trying to achieve an optimal or maybe like an impossible task that the model is not able to learn that minima, like a global minima into the model. So have you come across, because like you said, like there would be n number of metrics that you can come up to optimize a platform, but the machine learning model is not simply able to learn. So have you done this trade-off where you are trying to find the most optimal set of metrics, and then you say, okay, let me use this algorithm and just try to optimize these metrics, and then we can see what the results look like?
Yeah, so generally, the way it works is like we have some kind of key metrics and we try to optimize for those. And there are like other conditions on the other metrics. So, for example, if it says that, oh, this metric, for every X percentage improvement in one metric, you can only regress the other metric by a maximum of Y or something like that,
Oh,
right? Some kind of trade-offs between those is then how you manage off. So, for example, like, if just a very simple case in terms of very simple metrics, right? For example, your accuracy is improving or you make a huge model, your accuracy is much better now, but obviously will have serving costs for it. But what we can say is like, oh, because the accuracy has improved so much and this is what we are gaining, this much cost is acceptable. But if the cost goes beyond this, we may need to like come up with some alternate techniques or some improvements. So that's generally how it's done. Like it's a trade-off between like there is like a currency. I mean, I think this needs definitely needs more work, and we are not like on we never think of it when you do academic work, right? Because
yeah.
those are not real problems, but I think these are like real problems happening, and sometimes also costing dollar value, right? High dollar value. So I think
Yeah.
yes, a lot of work needs to be done in like establishing what are these exchange trade-offs between different things and how do you do it more effectively.
Yeah, I think that relates to the phrase very accurately, right? Like big with big power comes great. Sorry, I think what's the phrase? I think with great power comes great responsibility. So it's like,
Yeah.
yes, the scale brings a lot of good things about improving these algorithms, but at the end, it has to reflect in certain kind of revenue value. But let me tie this thing to one of the things that you said is interpretability, right? Which is very interesting to me because if in terms of vision, we have seen these kind of approaches, like let's say using gradcam and those kind of approaches, and this is again like a very simplistic academic approach to understanding what interpretability is. So we know what the model is looking at. How does this look when we are trying to debug a recommendation algorithm? Like, do you use some kind of manual interpretation techniques to see what's going on within the model, where you are like using perturbations, like what if I do this and what if I do that, and then using that difference to understand what are the algorithms doing? Or have you come across any kind of sophisticated ways to interpret or introspect an algorithm's working?
Yeah, I think interpretability in this case is more of like just trying to understand like, oh, you have for example, you get like if you're optimizing for, like, for example, logistic loss, right? So you may have like whatever normalized cross entropy, for example,
Yeah.
and try to find those buckets, like try to see, oh, what are the best examples, what are the worst examples, and then try to see why it is good, why it is bad. Similarly, like, different pockets, right? For example, if you're trying to find on a particular segment of users, you can try to get that segment and see, okay, how is my model doing on this segment versus
Mm.
that segment. And then you can also understand, like, what are the features that are playing in, like what are the most important features that are using that are being used to predict to predict values for this particular segment versus that segment. So that way you can understand, like, oh, these features are more useful in here versus there. This is what the model is doing here versus there, and then again that opens up opportunities, right? For example, if you see gaps, one good way, like in general ad systems, is checking calibration. And calibration means what is your sum of, like, what's the sum of the predicted value divided by what is actually observed value. And
Mm.
this is important because, like, calibration defines how much you charge advertisers. Like, if you are under calibrated, you're charging advertisers less and you're losing money. If you
Yeah.
are over calibrated, you're charging advertisers more, and then it's likely they will not come to your platform because it's costing them more, right? So it's a very subtle balance. And then understanding, like, which segment is your model over calibrated or under calibrated on, that will also, like, help you build better features so that you can fix that miscalibration in those segments. So model interpretability is more in, like, terms of, like, oh, what kind of segments you are doing bad on versus good on, and what features are used, and then developing more on that to improve the situation.
Hmm. That's very interesting. I mean, yeah, now that we are chatting on this, like it feels like a very moving target. There is that it's very hard to chase the optimal set of best case scenario, because most of the models, when we work with like a simplistic vision or language model, like we can see, okay, there are two things I can see my solution approaching or converging to a solution. But in this one, it feels like there are lots of parties involved, and we are trying to optimize it for a lot of variables. And one of the key things that I've seen for most of the social media channels, and feel free to take this like to a very general perspective, is the kind of contents that are being produced nowadays varies a lot. So I think, let's say for YouTube, there was a scenario where people were uploading long form of videos. You have 10 minutes, 15 minutes, or maybe someone like me who is uploading like maybe 1 hour of content over here, and then they're using these algorithms to find these metrics. Versus now there is a trend of submitting a videos of like less than a minute, like Instagram, Facebook, and lot of other platforms do that. So does this change, like working as a researcher or working as a technical person who is trying to now again getting these kind of metrics, because now you have like a very short amount of video, high amount of engagement, or even bad engagement? How do you, like, does this change the design of experiments, algorithms, and pushing it to production?
Yeah, yeah, I think this affects a lot, right? For example, like, you have situations where you have long form as well as short form videos, and many of these platforms today are serving both because that's the need. So, for example, here on ranking events, you may have to develop new ranking events. For example, if you had a ranking event just predicting, oh, if how much the user will watch, right? If you have a long video, user will generally
Mm.
watch more if you have,
Yeah.
than if you have a short video. Other ranking events used to be like, oh, what percentage of video you will watch, right? Again, there that will be more biased for shorter videos, because in shorter videos, if it's a 10-second video, you can easily watch 7 seconds and you are like 70% through it, right? So
Yeah.
both of these technically don't directly work. So now, you need to come up with like new ranking events that will effectively rank both these videos together. Like, and the way to do it is, I mean, one of the way that I think was published recently was normalizing the engagement between like different duration buckets, and using that to rank these like heterogeneous length content. So that
Mm.
is, coming up with these new events is one of the part. Another one is also understanding context. And this is important because, for example, like, imagine I'm sitting outside my dentist's office, just before my appointment, I'm scrolling through, right? At that time, I really want to watch really short videos.
Yeah.
Versus if I'm just sitting in my couch in the evening, I am open to watching long movies, right? So time of the day, location, even scroll speed, I think on mobile devices, right? If I'm scrolling really fast, probably it means I have less time. I want to
Uh,
watch something very short versus, oh, if I'm scrolling slowly, network speed, like all this is like context, right? So if I'm on a good network speed, maybe my long video will buffer and I can watch it. But if my network speed is maybe slow, I'm more likely to watch shorter videos. um, Also, like on this part, right, I think another very interesting part is, with shorter videos, generally like the engagement has become passive. That means users are not explicitly leaving a lot of, I mean, this is just a hypothesis, I feel. Users are probably not leaving a lot of explicit engagement, like you're not liking, commenting the video. You just want to scroll,
yeah.
scroll, scroll, watch it very fast. So in this world, right, and again, like comes back to the point of understanding this satisfaction, right? You need to understand satisfaction from implicit signals a lot more.
Yeah.
And I think in this mixed world, it's like going to be very interesting how that is done with long versus short videos.
Yeah, that was actually my basically intention for this particular question, because I feel like, because as a user, I try to also understand how these kind of things can really help the platform people to understand. And previously it was better, like you see a video, let's say you have like a particular time set, like say 10 minutes. If the person is seeing it for 2 minutes, it clearly indicates something like in a very explicit signal. But nowadays, like if the reels or any kind of videos are like less than a minute, like even the worst case for me to learn like what the video is doing is like less than a minute. So it's very, like you said, because people won't be in that particular like 100% focus when they're using these platforms. So it's very hard to, and it feels very interesting, like you said, like the scroll speed and everything. So it feels like every particular action that you're doing while on you are on these platforms is being used as a metric, which is very interesting. And yeah, it's a blow up of content nowadays, so it's like more important than ever to define good recommendation systems. So
Yep.
yeah.
Yeah, for sure. And you need to again take care of both the sides, right? You need to give the most relevant recommendation. At the same time, you need to grow,
Yeah.
create the right set of creators. And then how do you do this is going to be like very interesting.
And this begs me the question, so like we have yeah, I think we have talked a lot about, I think, metrics, right? Like, so it feels like an impossible task to first of all define, like you said, like it differs a lot of times. We have talked about challenges like trends, adapting to different kind of contents, adapting to different time durations of contents, and then optimizing it from different parties. So let me learn and maybe get a bird's view angle of your role. So you are working as a tech lead at Meta or maybe Facebook over here. So what does this particular role entail? First of all, like what kind of things that you do when like what does the like a day routine like look for a tech lead at software engineer at Facebook, let's say?
Yeah. So I think there are various aspects to the role. Like one is on tech leadership, so which is around setting the right goals for the team, defining the roadmap on in the technical sense, like what we'll be working on, what we should prioritize over others, and that is by understanding what is the potential impact of the work versus like how much effort it needs. um, then coming from there to like project management, which is managing the project planning, prioritization. Our goal is to deliver on time and a high quality product, right? So how do we do that more effectively, at the same time having opportunities for people whom we work with to grow in their careers, right? So kind of now we have, oh, these are the projects who would be the best people, and it's very bottoms up in most of these companies. So people get to choose what they really want to work on. And apart from, so this is more on tech leadership, project management. Apart from this, it's more of like strategic planning, which is like figuring out, oh, what is the long term vision of the work. Understand different stakeholders, right? We have external stakeholders, which is like users, creators, all these stakeholders, as well as we have internal stakeholders who are like maybe data scientists or product managers, how they are thinking of it, aligning the vision and then building a good solid tech roadmap.
Yeah.
to kind of cater to all of these. I think that's mainly like a high level view of the role.
I see. I see. And I can hear a lot of things that you just mentioned that I would say is not a part of any software engineers undergrad or grad degree requirements, right? Like you don't learn the skills of talking to clients or talking to different sets of users for these particular platform. So can you tell more about like how did you particularly build this expertise for taking the leadership on these kind of projects, because there is a lot of things that you learned apart from just being a good programmer, good researcher, or good person who understands these algorithms or maybe any kind of tools that a developer uses. So what was the transition like? How did you over the years transition to a role from just being a software engineer who takes sprints or any kind of projects to now taking leadership, taking the project from scratch to something that's tangible?
Yeah, I think over time, as you work on projects, as you understand the whole landscape, you can work on like setting the technical direction, right? Like for example, you can start at your project level. So when you're working on a project, oh, you did this. You try to find out what are the opportunities to improve or what we could do next effectively, right? So that is basically setting technical direction at the project level. Once you understand the whole landscape or the whole like the mission and the work of the team, you could do this at a broader team level. At the same time, you can focus on like how we build like leadership skills, right? So I was the one who was like trying to resolve conflicts, I mean technical conflicts, because people, if you work with strong people have strong opinions, right? And there could be differing opinions. So
Yeah.
how do we resolve conflicts? How do we ensure good communication? That means both upward communication, which is trying to highlight the work of our team, and downward communication also, like trying to get from all these stakeholders, trying to see okay where their priorities lie, how we can kind of improve them. So communication on both sides, making sure as you grow senior, you will have opportunities to coach and mentor other people on the team. So trying to do that. I did a lot of that, influencing even other, influencing these cross-functional folks, and helping build the vision, right? And then that you could like do it through a lot of the technical parts of it. You can learn through like what others are doing in the industry, through like different events, papers, all these things, and all the strategic as well as the leadership skills you can build through the team. And one thing you can do is like I got a lot of support from a lot of mentors. So like seek mentors is what I would advise in general.
I see. And do you see any of the red flags that you normally see people who fail to understand these kind of leaderships, as in like a particular certain set of skills that you would recommend anyone to learn in the early in the career in order if they want to transition to these kind of leaders? I mean, you did mention few of the things like what are
Yeah.
the to do's things, but do you feel any kind of red flags that you see in people who you would try to say, okay, avoid this particular thing if you want to transition to a leadership role later in your career?
Yeah, I think a couple of things that not particular red flags, but what I would suggest is like take ownership of problems and like go deeper. I would suggest, especially like early in your career, you should make sure that you go deeper into machine learning problems. Like try to be a end-to-end machine learning engineer. What I mean by that is like if you are kind of owning only the model building,
Yeah.
try to see like how you can build the pipeline, how you can improve the pipeline for training data, for example. How can you do like effective evaluation? How can you review your candidate with other folks, and make the launch happen, right? So I think you should like go beyond your immediate scope to be a more of an end-to-end ML engineer. This will really help you understand what are the challenges that are faced by the team, and that's how you can build. Like another advice I give folks is like try to focus on work which has higher impact, even if it would mean like a little bit higher effort. So I feel like sometimes people try to go more on the quantity side, and by somewhat, oh, I do a little bit mediocre work, but I will do a lot of these things and it will be fine. But I think generally, if you do fewer things better, deeper, those generally help a lot more. And try to think on a team perspective, right? I think the natural way to grow is the team should automatically start seeing you as a leader. And the way to do it is like try to pull the team up, try to empower the team to be successful, even outside your immediate scope or project at that time. So I think these are like general advices I give folks I work with.
Yeah, no, definitely that definitely makes sense, and I can see that in different domains itself. You saying it from industry perspective, I also seen this from academic perspective, where the people who are your mentors, they would like to see these kind of ownership. Like, I mean, there's no other word for that, but like taking ownership, like that means taking like mentoring people and making sure the project progresses through your particular vision, because everyone has their own sets of skills, I would say, and set of exposure. So let's say if what I bring to the table is different to the other person, that's like a valuable skill that you can add. And if you can provide like a different diverse perspective to taking this project forward, that really helps. So just being like a person who takes tasks and completes them, that's not more than enough nowadays. So it's
Yeah,
like having that particular extra opinion sometimes helps. And like you said, like people who are more experts, they have their opinions, and that's for good, right? It brings kind of a diverse perspective to bringing something new to the table.
yeah,
So yeah. And one of the key things, like as we talk about candidates, is also from understanding from like cracking these kind of job interviews. Because like you said, like if you want to work at higher impact or higher deliverable projects, like one of the key things is to maybe be in the right place. And being in the right place has a lot of competition nowadays. So what according to you is like, because you have been on the both sides, because now like you are a senior software engineer, so I'm sure you might be in the process of like hiring excellent candidates for your teams and making sure what really you would be looking for. So can you tell things from both the perspective, because at some point I believe you would also have been in the same pool of like applying to 100 companies and getting it, maybe let's just like one call back and those kind of scenarios, versus now you understand what are the pitfalls or maybe like a warning sign that you see in a candidate. So in like, to rephrase the question, what do you think first of all makes a good interview candidate, where you would see, oh, I really like this person, I might I might would be interested getting this person on my team. What does that look like?
yeah. So generally, I mean, all these machine learning companies evaluate the candidates based on what they feel the candidate can contribute to ML improvements at the company, right? So I think one of the main aspect here is on machine learning understanding. So imagine that I give you a project. Can you really understand the problem and my solution? Can you, like, for example, propose different variants to the solution and explain like trade-offs, right? So, oh, what is the pros and cons of your solution versus my solution? Ask questions. I think one important part is like framing the product goal as a machine learning problem, and figuring from there, what you can use as training data. For example, you have a ride sharing company, right? They want to go into being a food delivery company, right? How do you bootstrap restaurant recommendations for this company? What kind of data you will use? Can you use like some ride sharing data and just to bootstrap, for example? Like, this is again the thing that we talked about in the past of
Yeah.
bootstrapping, right? Recommendations. Can candidates, interview candidates, propose like good baselines, evaluate what kind of metrics they will use, discuss all these things. And we generally want candidates to go into details, right? Not just like hand wavy stuff. So for example, if you ask, oh, what features will you use, right? And if everyone, almost every problem needs user demographics features, right? So if you just say, oh, we'll use user demographic features, yes, but that's there for any other problem, right? What's the special, what other things will you do specific to this problem? And in the similar flavor, like, can you criticize like various approaches? Can you figure out like model is biased, or how would you like figure out overfitting? What objective function metrics you will use, how you will debug, all these things like become important. So like really understanding machine learning, especially related to like any problem or project you are given, end to end, and going into specifics, I think that's key.
Yeah, I think so. I think the focus should be on critical thinking of these kind of technologies. So it's just not enough if you just know how the algorithm works
Yeah.
or how people have been using it. But let's say if I give you a scenario where you can adapt to these particular scenarios, like, I mean, yeah, I really like the question where you it's, I mean, for people who might be listening, this would be like a very tentative thing to maybe like a mock test to work on, is like, how do you bootstrap, like you said, like the right shader algorithm. And I can relate to like most of the interviews that I have been through for my internships, and they typically ask like a very open-ended question, but
Yeah.
most of the times they are not looking for a solution. They're just trying to understand, has the person really learned, like let's say, even if you're using association rule mining algorithm, that's like a very simple way to understand user preferences, but like, how do you apply this one to a problem that I have posed on you, and what kind of metrics? I believe like one of the very fantastic interviews that I have had was where the person asked me, what exactly can we get from specificity and sensitivity of a model?
Yeah.
And I was really interested. Like, I got the internship after that, but like I was very fascinated by just understanding those two metrics and how much importance that particular metric has when you're dealing with uh, medical scenarios where you're applying a model and the goal is to do a certain set of tasks. Because a lot of times doctors would be interested in understanding what are the scenarios where the model is classifying this negative patient as a positive versus a positive as a positive, and then again the positive as negative. So I was really fascinated, and that's when I learned. Like, I went back after the interview and read a lot of more things, like, because it's one of the simplest metric, right? Like, there's not much to understand. It's
Yeah.
just a fraction of predictions over total values. But understanding the key of like where exactly we can use this, and what particular things you can take back, because if the specificity of the model is very low and sensitivity is high, what does that mean? How do you
Yeah.
go back and improve the algorithm versus the vice versa of those scenarios?
Yeah.
So
Yeah.
yeah,
Now you have, all these off-the-shelf tools, right, that, folks can use to directly build the models. But really understanding, why this model is better over any other, or why this metric is better over any other, I think that is what people are looking into really, and those thinking skills.
yeah, and that really also marks the problem. Like, if you are just a person who can just import because like you said, like, it's easier than ever to build a model. I can just give you a data set, and PyTorch and lots of other tools have made some very fantastic plugin tools where you just do this and it produces certain
Yeah.
results. But I think if like a way to understand if the person has actually spent working on these models is to ask these questions, or maybe like what we say, like reading in between the lines. So I normally use like reading in between the lines of codes, right? Like, because if you have implemented things from scratch, you ask these questions and you can answer these.
Yeah.
And do you have any other further insights? Like, what does, like, most of the people, like, this is one of the questions that I get asked a lot, is like, there is a lot of structure for software engineering interviews. So, like, there are lots of websites that provide mock interviews and mock set of questions that have been asked in the past, and they can get an understanding like what kind of roles are asks what kind of questions. But it still remains like a very big question mark when it comes to machine learning interviews, because like you said, um, people are just trying to ask very open-ended questions. Is that the bottom line that people should be aware of when we are applying for machine learning interviews? Like, if you want to hire a machine learning engineer, what kind of things that you would be ideally looking for, apart from just open-ended knowledge of these machine learning things?
Yeah, yeah. I think generally, like, a very base case is algorithms and data structure for most of these companies, and that's because we expect like machine learning engineers to be having the skills of a very like baseline software engineer at least, so that they can contribute. Sometimes it's not only about like building machine learning models. Sometimes like you should know how to deploy them and all these things, right? So that needs those skills. So that is baseline. Then generally it's like a machine learning design interview, which again like tries to. I think this is what we discussed was more of the design interview where we try to figure out, does the candidate have a good product sense and understand how ML fits in. Like we have these complex systems, right? And for example, newsfeed, you have multiple tasks. You're trying to combine these multiple tasks is in like the conversions, right? Multiple types of conversions,
Yeah.
and there are many product aspects too, right? For example, like if a user updates a story, right? Or there are seen stories, unseen stories. How would you handle all these kind of proactively thinking, connecting this product sense to a ML problem, I think helps a lot. For senior candidates, we try to look into problem exploration. Are they able to explore the problem well? Are they able to solve it using come up with the right metrics, like non-trivial business goals, and formulate them as like ML solutions and with ML metrics, right? How do they debug, deploy, monitor these systems? And details on features, architecture. I think that is anyway needed. So this is like machine learning design. Apart from that, there is like a behavioral interview, which is mostly trying to understand like what is the motivations of the candidate. How do they handle various types of situations? What kind of scope have they worked on in the past? Like what kind of experience they have. So I think this is at a high level, like these three types. I think of interviews are there for any machine learning engineer.
Makes sense. Yeah. Yeah. That sounds about right, even from my experience. Like, yeah, I mean, for most of I think there are these three broad categories for most of these roles. One is software engineer, which is typically related to work of like production level, where you're trying to build a solution based on technological platforms that whatever the company is working on, then pushing it to production where it serves a particular purpose. Then I think there are these in between domains, data science, machine learning engineers, who are trying to understand a particular machine learning model, but the goal is to just take that one into the existing software cycle and then push it to production, which again serves a particular purpose. And I think then there is this research scientist interviews who are trying to understand, like, if there's an unknown problem, how do we map it to existing set of algorithms, maybe innovate, maybe not innovate, and use off the shelf machine learning algorithms. And then again, this goes back to like the whole cycle of machine learning engineers and then software engineers who are trying to build a product out of it. So yeah, I think it's now getting a lot better, because now we see a lot of companies hiring these hiring for these roles, and it becomes much more generalized.
Yep.
So yeah.
Yep.
And one of the key things that I also tend to ask most of the guests is, because a lot of people watching this particular podcast would be people who are interested in AI, and they are trying to understand, because AI from the outside perspective seems very lucrative to anyone, right? Like if you ask anyone, like, yes, I mean, anyone wants to work in AI because it's the big trend nowadays. But as a person who is like in his or her bachelor's or master's degree, one of the key things is to deciding what is my interest, right? Because vision, it also sounds very interesting. Reinforcement learning, we see AlphaGo and a lot of other solutions. Language models, chat gpt is like now a big thing stealing the show. So there are lots and lots of domains, even recommendation algorithms. Most of the big companies are using them in some or the other way. So first of all, like, can you share your experience? I mean, you did explain more about like how did you get into recommendation systems, but what kind of tips you would give to someone trying to break their career into these tools? Like, everything sounds very interesting, but where do I get started? How do I get started? And how do I build a career that can sustain for a long amount of time?
Yeah. What I generally recommend folks is get a very basic understanding of machine learning. I think especially if folks are trying to go from like software engineer traditional role to machine learning role, I would suggest brush up basic probability, statistics, linear algebra. Because after working for a lot of years in a traditional role, sometimes you lose touch on all of these.
Yeah.
I think having basic ML knowledge is important. Most of the knowledge between these is transferable. So for example, we have transformer architectures. They are used, they started in one domain, but now they're used across domains. Most of the solutions are, so if you know one of them also well, it's very easy to move to any other application. So I would suggest get a very basic understanding of ML. And if you're in college, or even if you're like a software engineer, I would suggest now, as we discussed, right, it's very easy to develop a lot of like experiences, right? So if you're looking for applied kind of domain, like try to build some experience. Either it can be an app, or any other kind of tool, right, using off the shelf techniques. So I think that will give you a very good understanding of the flavors of what is out there also like try to understand what you're using. Don't just look into importing those libraries. Try to understand like what's going on there. But I feel like any one domain, if you know or if you explore, it's very easy, and like not a lot of the knowledge is transferable between these domains. So I would not think
Yeah.
like it's very difficult to move between these. I would suggest like get the basics right, get some experience, and then it's very like you can figure out where your interests lie.
Yeah, I think most of the topics in research are transferable. Like I think most of these vision topics or language topics, like you tend to learn these topics in a very open-ended or general perspective domains, and then you try to apply this to whatever you are asked for or whatever you want to apply for. But would you say the same kind of advices would hold for someone who is working as a software engineer at some company and he or she wants to transition to an ML role? Because like for university students it's easy, right? Like I can take up a course and say that I worked on this one, but it is not very often the same for people who are already in the industry. It's very hard to make a dent in their resume or in their one page word document saying that yes, I do have some background in machine learning engineers. Like, do you have any advices for people who might want to transition within industry from software engineer to machine learning roles?
Yeah, I think the easiest is probably like, try to find opportunities within your immediate teams, or, just outside your immediate teams, or some teams that you work with. I think if you can make the transition within the same company, if you're already in a company, I think that's the best kind of approach, apart from maybe building some tools or some experiences on this side. I think that can help. Like it's easiest always to switch a little bit and try to understand within your own company the problems and try to contribute in some way, and then if you want to go full fledged and stuff, like it becomes easier from there on. So I think that's the easiest, because if you're already in a software engineer role at some place, it's very difficult to directly switch to a machine learning role at a different place. So I would suggest like making the gradual shift um, to where you want to be.
Yeah, that makes sense. Yeah, and that would be like that actually makes more sense even from the candidate's perspective, because it's very redundant if the like the person leaves the company and tries to develop his or her own base somewhere else. Rather, if you know the team, you know the product, and if you can bring particular uh, novelty using machine learning, that would actually, and because I have known a lot of people, like I have a friend who is working on a database team, and they're like the existing methods never use any kind of machine learning approaches. And one of the key things that he was trying to optimize was for, I think, the number of virtual machines that are being created by those platforms. And he just used a very off the chart, I think, if I remember, like it was some clustering algorithm. I think it was K-means, and he was just like summarizing this particular data to his manager, and he was he was very intrigued, because like what kind of metrics these kind of tools can tell. And I think now he's transitioning to like a data scientist roles and all those kind of stuff. So I think that really makes a lot of sense. Like if you can just pick up a project and you can say read up these kind of courses and contribute to your existing team's revenue, and that creates a difference.
Yeah, and I think there is a mutual benefit for, you are able to explore the area that you always wanted to be. There is also a benefit for the company, right? They're
Yeah.
getting some new perspective, someone who's interested in exploring this further. So I think, yeah, this generally like is the best fit, I would suggest.
Yeah. And the other thing is remaining updated to lots of research that is being published, right? Like I like, to be honest, I haven't been reading much more on recommendations, but I think in general AI field receives a lot amount of publications. I'm not sure if this is just specific to me, because I got started in this field a little bit late, or maybe like when it was at the lower peak of its boom of AI. But I feel compared to other science fields, AI receives a lot amount of publications, which also includes a lot of bad publications where people are not doing or maybe claiming something novel, versus there are lots of other novel contributions too. So personally, how do you like? Have you figured out some kind of best practice that works for you to remain updated to these kind of technologies that are relevant to your work? And if so, what they are?
Yeah, I think that's a very good question. I think it's more relevant today than ever, right? Like the field is completely booming, and I think there are like 50, even if you open like archive, there are like, I think more than 50 papers every day, every
And
day. So it's super difficult to keep
and
track. So
it's
Yeah.
And it's more important to build like a good recommendation system for maybe paper, scientific corpora, right? Like
Yep.
that really serves your purpose. But yeah, like
Yeah.
please continue.
Yeah. So I think what I found out initially, which was pretty, I mean, worked till a long time, was I think Twitter, keeping updated with like some folks I know who are like, in the field and doing good work on Twitter. Even like some filters on archive, like search basically. So you can have some filters on the search for archive search so that it gives you papers exactly in your domain and so on. But I think now even that's, reaching its limits. In general, in the company, in our team, we actually have like a reading group. I think that's been pretty good. So we are like kind of democratizing this finding of papers and reading them. So every week we try to read two papers, and there is one presenter who is leading the discussion, and other people also read the same paper. They try to ask questions, and there's a rotation of like these people who are trying to present, right? So within our whole team we have everyone present, so like two papers per week, and so on. So I think that has been pretty good. Like at least you get a flavor of what you can use in your work, and build on top of it. So I think
Yeah.
that's been a good practice in general.
Yeah, makes sense. Yeah, I think reading groups, even in my experience, is maybe the easiest way to get some good summaries, because if you build a repo with, let's say, five people who really you really understand their way of summarizing papers and how they read paper, and if you have a good repo with all of them, it really multiplies your ability to read good papers and remaining updated. So yeah, reading groups I feel are like the most effective ones to um, get to know. And I think it's fun also, I think, because I have seen this very good bias, like when people read papers, like they have a certain way of reading or maybe understanding summaries and maybe understanding conclusions based on their own previous preferences. And that helps me, because when I read the paper versus when you read the paper, when we talk more about that particular paper, it brings something new to the table. So
Yeah.
yeah.
Yeah. Totally. Yeah.
And one of the last questions before we sign off is like, do you have? I mean, we did talk about, because I feel this particular question would be redundant, because you already mentioned a lot of tips for people who are in research, people who are in software engineer roles, and also people who are in general interested in recommendation algorithms. But I'll still keep this particular question open to see if you have any more tips or advices to any young students who are in the field of computer science. Like, what kind of things you would advise to maybe like a young brother or sisters of yours, based on looking back at your career? Like, what kind of things you think would have helped if you had received that particular advice a little bit early in your life?
Yeah, I think that's a very good question. I think in general, right, like I think one advice I always give, I think I've already talked a bit about it, is, focus a lot on like quality. Sometimes, doing the right thing is going to be difficult. It's going to take even more efforts. It's going to be like you feel, oh, that's a bit more painful than taking the easy way out, right? Let me take the easy way out. And so I think doing the right thing, there is a lot of value, even if it is not immediately realizable or immediately like understandable. There is long term, both like satisfaction on your side, as well as like long term value you can gain by doing it in the right way and understanding the whole thing. So I would say always bias towards doing the right thing, understanding things deeper, and exploring the space, because I think that's where you will pull up opportunities. That's where you will like learn the most, and be at your best self. Like so that's one very strong advice I give everyone.
So by right thing, you mean like not focusing on the low hanging fruits of a particular application or any kind of things you are learning for, but rather diving deep, even if it is redundant. Is that correct?
Yeah, low hanging fruits. Yeah, I mean low hanging fruits. I mean, yeah, if you can get it, definitely get it. But I think a lot of value will come by going deeper. In general, we kind of lack, or we have a very low number of people who really go deeper. And I think that's where a lot of like innovation comes in. That's where a lot of like new ideas, or even ideas of how to improve what is already built, right? That comes in. So yeah, that's what I meant.
Yeah, no, I love that. I think with more and more people nowadays learning machine learning, and it's becoming much more accessible nowadays. So it becomes really critical to filter out people who actually have a good knowledge, because it's like relatively, I would say, like 4 years ago, even implementing a machine learning model was kind of a skill, right? Like
Yeah.
not a lot of people can train or maybe train models on GPU, because like the art of GPU programming was like a challenge. But with tools like TensorFlow, PyTorch, who have made it easy, it's like nowadays easier than ever. So I think nowadays, like, it becomes very challenging to stand yourself apart, and in that case a very core understanding of these algorithms and uh, mathematical foundation for these kind of tools is becoming more important. So yeah, I love that particular advice.
Yeah.
But yeah, with that, I think those are the all set of questions I had for you for this particular podcast. And yeah, it was very fascinating. I think we covered a lot of about I think video recommendations in general to Facebook platform, understanding how do we design these kind of problems, because that would be something most interesting. Like we discussed, like I think people would be least interested in like what kind of algorithms, but how do you design these set of problems. So we get to cover these particular things, and some very nice tips from you to understanding how these roles transition to real world scenarios where you are working at scale. And yeah, some tips and advices for people who want to transition and get started off in this career. So thanks a lot for sharing all these advices. Hopefully it's equally insightful for people who are listening to this particular podcast, and I'll be leaving a link to your homepage, so that people, if they have any specific questions, they can directly reach out to you and maybe learn more about your background, like how you have been in these fields and how you have transitioned to a fantastic role. So once again, thanks for taking a time out on Sunday. I really appreciate that, and hope it was fun for you too.
Yeah, thanks a lot. I think this was very insightful, and I'm happy to talk more on this. Thanks a lot. Thank you.